Students, this is our last unit of this semester, Unit 4, Similarity. We're dealing with Lesson 4.1, Proportions and Similar Shapes. Make sure you get the date, time, location, and a parent sign off. There are 4 things we're going to accomplish. 1, we're going to explain the difference between the concepts of ratio and proportion. 2, actively solve proportions where the key to multiplying is not multiplying, but factoring. Where the key to multiplying is not multiplying, but factoring. 3, understand the impact that differing units have on ratios. Understand the impact that differing units have on ratios. We're going to define similarity and use it to set up and solve proportions. Those are our 4 goals. Let's focus in on our first goal today. We are dealing with the concept of similarity, ratios, and proportions. By the time we're done today, you'll understand the difference between ratio and proportion. You'll be able to define the word similarity and scale factor, the extremes and the means. Step 1, we're going to explain the difference between the concepts of ratio versus a proportion. Basic definition of a ratio: a comparison of 2 numbers by division. A comparison of 2 numbers by division. Very important when you're working with units, centimeters, meters, feet, yards, you must get into the same unit before you can even make a ratio. You must get into the same units before you even get a ratio. On that note, if you can find your units page, it's cardstock, it's the beginning of your reference booklet. You need to familiarize yourself with that. It looks like this. That's your units page. You need to familiarize yourself with this units page. Styles of ratios. Using words, 3 to 4. Using a colon, 3 to 4. Fraction, 3 over 4. So the first goes in the top, the second goes down below. And then you think, what is 3/4 of $1? That's how you translate to a decimal. That's the simplest way. Most of you can think in money. 3/4 of $1 is 0.75. So what you see right now, very importantly, is that all decimals and all fractions are ratios. A proportion is an equation of ratios. So when you have, remember we just said that fractions are ratios. So when you have an equation of 2 ratios that are equivalent, that whole thing is called a proportion. So the individual fraction is a ratio, and the entire thing is a proportion. Go ahead and write this proportion. It's a true proportion. 2 over 4 equals 8 over 16. So let's order these from least to greatest. So there is 2, 4, 8, and 16. The two numbers in the middle we call the means. Let's multiply those. The two numbers on the outer, we call those the extremes. Let's multiply those. So you guys notice this one simple thing. The product of the means is the same as the product of the extremes. That's a very technical way of saying something you're already quite familiar with, cross multiplication. When there is a proportion, when you cross multiply, you're going to get the same thing. That's the product of the means equals the product of the extremes. We're going to accurately solve proportions where the key to multiplying is not multiplying, but factoring. The key to multiplying is not multiplying, but factoring. So let me show you what I mean by that. We're going to cross multiply here to solve this proportion. So we're solving a proportion. Remember, a proportion is an equation of ratio. So that green is a proportion, and that blue by itself is a ratio. So the product, we're going to cross multiply. We have 15 times k equals, and then 35 times 33. Don't even dream of looking at a calculator right now. Most of you are like, I don't want to do 35 times 33. Well, guess what? You don't have to. The key to multiplying is not to actually multiply, but to factor. That way you can do this without using a calculator. So we're going to solve here by dividing by 15. Ready? I'd like you to circle 15 and 35. And you ask yourself, what goes in both? We know 5 goes in both. 5 goes in here 3 times. 5 goes in there 7 times. Now I'd like you to box the 3 and the 33. You ask yourself, 3 goes into 33 how many times? 11. So we cross that out. That's a 1 and 11. The only things left, you multiply straight across, is we have 77 over 1. So our proportion is 77 is our answer for K. Let's try that again. The key to multiplying is not to multiply, but to factor. I'd like you to draw your cross multiplication arrows. Notice I did not multiply 10 and 14. Instead, I'm going to divide out by 2. Now, it doesn't matter if I take the 2 here into 14 or whether I take the 2 into the 10. It doesn't matter. Just choose one or the other. I'm going to take the 2 into the 14. Once you divide it, it's only one time. That's 7. And then you simply multiply what's left over. The key to multiplying is not to multiply, it's to factor. Notice we didn't actually multiply there, we factored. So that's solving a proportion. Another way to look at a proportion is the fact that it's a reduction. So if I said something was 25 to 75, and I want to change that into a ratio, I reduce, and that's going to be 1 to 3. Why? We did 1 times 25 and 3 times 25. So when you're working backwards, you can see that there has to be a common factor that both fit into. Let's read this problem. We have two supplementary angles with a ratio of 3 to 2. Find the measure of the angles. Supplementary. Sum 180. Supplementary, sum 180. It's a ratio of 3 to 2. Now, a ratio is the reduction. So the way you want to think about it, it's technically, if it's 3 to 2, it's 3 times something over 2 times something. Problem is, we don't know what that something is. We don't know what that something is. It's a 3x and 2x ratio. And we know that they add up to 180. So we take that ratio and we change it into an algebra problem. Five goes into 180. Do this longhand with me. So it's 36. Now 36 is not your answer. 36 is simply the something. So to get the actual degrees, 2 times 36 is 72. And 3 times 36 is 108. If we were to reduce 108 to 72, we'd end up with a 3 to 2 ratio. I'd like you to do this page on your own. Pause the video, do the work, restart, have a red pen handy. Pause. Welcome back. Let's see how you did here. Cross multiply. I'm going to do that. 3, and then 3 goes in there 5 times. X equals 5. A few of you were able to simply do that in your head, and that's perfectly fine. Cross multiply. This one was complementary angles, have a ratio of 4 to 1, which means that's a 4x relationship that adds up to 90. So it's 5x equals 90. In this case, x equals 18. So this is going to be 18, and 4 times 18 72. All right, you should check correct in red pen if you just got those correct. Nice big star, smiley, something. I'm such a brilliant marking. Remember, when you use ratios, you have to be careful with differing units. Differing units have an impact on ratios. Remember, a ratio is a comparison of two numbers by division. It's a comparison of two numbers by division, but I'm going to add one caveat here. It's a comparison of two numbers by division that are in the same unit. If they're not in the same unit, you can't get a ratio. So before you can get a ratio of any kind, you must first be in the same unit. We'll do a couple problems together. On that note, it's really important that you have this units page handy. Right here, you should have this units page handy, right where you can see it. Let's read this together. Trish needed 3 feet of Velcro for every 2 yards of fabric purchased to make a table banner. So the Velcro is going along this edge here. What is the ratio of Velcro needed compared to the amount of fabric? What students normally just see with this problem is they go like this. Oh, the ratio is 3 to 2. Ta-da! I saw a 3, I saw a 2, left to right, I'm done. No, you are not done. That, my friends, would be wrong, because watch very carefully. It is 3 feet of Velcro to 2 yards of fabric. In order to have a ratio, you must first get into the same unit. It's always best to go in the smaller unit. So I'm going to take yards into feet. I know for every 1 yard in the first dimension is 3 feet. So if I have 2 yards in the first dimension, I know this is going to be 6 feet. So the ratio, I have 3 feet Velcro for every 6 feet fabric. Notice we're now in the same unit. Now that we're in the same unit, you can get your ratio. So the actual ratio of Velcro to fabric is 3 to 6, and ratios, by definition, you always take to the lowest form, 1 to 2. The correct answer for this is not 3 to 2, it's 1 to 2. Let's do another one. An industrial-sized recipe to make 300 chocolate chip cookies calls for 800 grams of sugar for every 2.5 kilograms of flour. What is the ratio of sugar to flour? So again, what students would normally do is they just see the 800 and the 2.5, and they would write 800 to 2.5, and then they would divide 800 by 2.5 and get some scary decimal and try to say that's the answer. It's not 800 to 2.5. By the way, that would mean it's nearly double the amount of sugar to flour by several hundred. Okay, so be very careful. 800 grams of sugar for every 2.5 kilograms of flour. You should be familiar with your metric system and the concepts of kilo means 1,000. You must have this page with the units memorized. You heard me right, friends, memorized. So I know for kilogram is 1,000 of grams. So I'm going to go 2.5 times 1,000, and that's 2,500. So now my ratio is 800 grams of sugar for every 2,500 grams of flour. Easiest way, if you have multiple zeros, you can cancel an equal number of zeros both ways. So we go like this, 1, 2, 1, 2. My lowest reduced ratio for every 8 portions of sugar, whatever the portion is, we need 25 portions of flour. Knowing you have to manage units, pause the video and take care of this page on your own. Pause. Okay, welcome back. Let's see how you did here. We're going to write a ratio here. And again, the most common mistake students make here is they simply go 44 to 2, and they go, oh, it's simply 22 to 1. That would be wrong, friends, because it is not the same unit. So you should have taken the meters into centimeters, and this is going to be 44 cm to 200 centimeters in a meter, so that's 200 cm. Now that you have the same unit, now you can reduce your ratio. We're going to divide both by 2 first. You should have gotten 22 to 100, and look, I can keep dividing until I get somewhere where I can't divide anymore. And that's going to be 11 to 50. So the accurate ratio of 44 centimeters to 2 meters is 11 to 50. 11 to 50. This one, a Harley-Davidson front tire travels an average 82 inches per complete roll. That means when this tire rolls, it's going to travel every spin, if you will, or rotation, 82 inches. I actually calculated that for an average Harley tire. So it rolls, and we're asking what is the ratio of tire rolls for a single mile. So we're asking ourselves how many 82 inches, what is the ratio going into 1 mile? Now, obviously, it's not 82 to 1, because that's not the same unit. So we need to get in the same units. This is a double conversion. Okay, first you look up how many feet in a mile. That's what people normally memorize. And if you come down here, and you should memorize this. This should be common knowledge, folks. There is in 1 mile in the first dimension, there's 5,280 feet. You should have that memorized. So we're going to go 5,280 feet, but the problem is we want to get into inches, so we have to times that by 12. So in a single mile, alrighty, from here, all you do, we now know we're inches to inches. We have 82 and 63,360. Simply divide by 2 and just keep going until you're all the way down. So this divided by 2 is 41. This divided by 2, that's 31,680. And 41 is prime, so you're welcome to check here just with your calculator to check that prime number. 31,680 divided by 41. That's not even, so your lowest ratio is right there. So your takeaway is this: there's no ratios unless you're in the same unit. Here's our fourth and final goal. We're going to define similarity and use to set up and solve proportions. Define similarity and use to set up and solve proportions. So the basic definition of similarity, the simple definition of similarity, is items which are similar. Have the same shape, but a different size. So in contrast, if you have two shapes which are exactly the same shape and the same size, we call those congruent. If they're the same shape but a different size, like t-shirts, small, medium, and large, we don't say they're congruent because congruency is same shape and same size. We say they are similar, and we use this symbol right here. That means similar. Same shape, different size. Say it out loud. Same shape, different size. That is the simple definition of similarity. The geometric definition of similarity is SCARE, S-C-A-R-E. It stands for similar shapes have congruent angles, side ratios equal. Similar shapes have congruent angles, side ratios equal. Similar shapes have congruent angles, side ratios equal. SCARE. Let me show you what I mean. These shapes below are similar. First, you check for congruent corresponding angles, which we see that we have congruent corresponding angles. Check. Now we check ratios. So we're going to go short side to short side. Reduce. 4 goes into 24. 6 times. So that short side to short side is 1 to 6. Long to long, reduce 8 and 48. That's also 1 to 6. So it's not the side lengths that are equal, but the ratios that are equal. If things have congruent angles, ratios equal, we say they are similar. Let's do some practice. In just a moment. Now, if shapes are similar, then you have to be able to find what's called the scale factor. Scale factor is always the ratio of the sides simplified. Scale factor, ratio of the sides simplified. Scale factor, ratio of the sides simplified. We're going to find our scale factor here from left to right. Before we do that, we have to align our sides. Be very careful. On the left, That's 10 is my short side, 14 is my medium side, and 16 is my longer side. Let's come over here. 15 is my short side. I can see 21 is my medium side, and then this is my long side. You must match the corresponding sides to get my ratio. So I see I'm going to go short to short, 10 to 15. Medium to medium, 14, 21. Reduce. Both of these are divisible by 5. Both of these are divisible by 7. Notice they reduce to the same ratio, which is what we'd expect because we already said that they are similar. So my scale factor here from left to right would be 2 over 3 or 2 to 3. Let's put this into practice. We're going to determine if the shapes are similar. And we're going to do that by checking for scare, congruent angles, and then ratios equal. So on the left, first I note that I have parallel lines. And if I have parallel lines, I'm going to stretch them out just mentally. And right away, if I have parallel lines, I know these angles, which are consecutive interior or same side interior, are supplementary. So if that's 80, this is 100. That's 100, that's 80. How do I know that? Because of look at the double arrow feathers. That means they are parallel. So now we look to see if our angles are congruent. If that's 100, there's 100, same position, there's 80, there's 80. It's also parallel going the other way. Notice the arrow feathers, which means this has to be 80 and this has to here be 100. This is 80 and this is 100 because of the parallel lines. So we just check that the angles are congruent. Now we check our ratios. Short to short, 7 to 14, that is a 1 to 2 ratio. And make note, it is the same thing all the way around. So my ratios are equal all the way around. So yes, this first one, yes, it is similar. Let's try the next one. Let's check first for congruent angles. Notice we have corresponding congruent angles. So that, for the moment, we're halfway there. Now, let's check our side ratios. Long side 16, long side 24. Reduce. 8 goes into both. So 8 goes into 16 twice. 8 goes into 24 3 times. So long to long, that's a 2 to 3 ratio. Let's check this. Top short, top short. 12 to 16. Let's see what goes into both. 4. 4 goes into 12 3 times. 4 goes into 16 4 times. Oh, look what happened. Here I have a 2 to 3 ratio. Here I have a 3 to 4 ratio. That means although I do have congruent angles, I do not have ratios which are equal. So I would say not similar. They are not similar. So that's how you test for similarity. Now, if things are similar, we have equal ratios, which means proportional. Remember, a single fraction is a ratio, an equation of fractions. This whole thing is called a proportion. Just an individual fraction, that's called a ratio. An equation of ratios is called a proportion. We're going to be using proportions in this entire unit. About 80% of all your work will boil down to a proportion. We're going to use a proportion to solve for unknown lengths. The image below is similar. We're going to find our missing side. So if we're similar, I know I have congruent ratios. So right off the bat, I'm just going to do one of these. Now, you need to carefully first color code the sides. Be very careful with this. Notice here, 24 is one of the shorter sides. So my short side goes with my short side here. My 36 is a medium side. That's my matching medium side. Colors really come in handy. This 42 is the longest edge. That's going to match with my longest edge. Match and mirror. Match and mirror. I could go, I match the sides up, and now I'm going to mirror the direction. If I start 24 over 4, then I can go left to right, 42 over unknown. Or I have more than one option here. Doesn't matter which one I choose, actually. Or I could do medium to medium, 36 to 6, left to right again, 42 over unknown. Either one works just fine. It doesn't matter. All right, I'm going to use this bottom one. We're going to cross multiply. So I have 6. I'm going to change that to an X just to make it easy to work with. And then here, 36x. And this is 6 times 42. The key to multiplying is not to multiply. Notice I didn't actually multiply 6 times 42. Instead, I'm going to divide out the 36, and now I factor stuff out. 6 goes into 36 6 times. Then this 6 goes into 42 7 times. Lo and behold, x equals 7. Which makes sense because I have here a 6-to-1 ratio all the way around. 6 to 1. So my unknown side there was 7 units. I'll do one more with you. It says find the variable and the side length knowing the shapes are similar. So once again, we know the shapes are similar, which means I can do one of these. Similarity means congruent angles, ratios equal. And because those ratios are equal, I can do a proportion. Okay, so let's look at what we have here. It says here the scale factor from A to B is 3 to 5. Be very, very careful here. Notice it's from A to B. If you look at your shapes, The 3 goes here with the A, and the 5 goes here with the B. Don't automatically go left to right. Look at your shapes. So there's 2 ways I can set this up now. Now that I've aligned my scale factor correctly, I could do this. 5 over 3. That's a 3, not a B. Equals, long side, 40 over matching long side, 2x plus 10. I could have also gone this way if I wanted to. It really doesn't matter, but what does matter is you must match the appropriate sides and mirror the direction, which means if you start left to right, finish left to right. If you start right to left, finish right to left. Now we simply cross multiply. Because I have a variable here, and I'm going to have to subtract something, that I will multiply out. What's really nice is you don't have to be left wondering whether or not your number is correct. If we think our number is 7, we're going to plug it in over here. So 2 times 7 is 14 plus 10, that's 24. Let's check our ratio. Remember, we want 5 to 3, and right now we have 40 to 24. You ask yourself, 40 divided by 8 is 5. 24 divided by 8 is 3. Look, it reduces correctly. So we now know that that 7 was correct. This page you're going to do on your own. Restart the video, and this page, restart the video when you're done. Okay, we're going to see if the following paired items are similar to begin with. And first we check for congruent angles. So I check my corresponding angles are congruent. So that one's good. Now I'm going to check for ratios which are equal. And I'm going to go 40, which is my long side, to 48. I see that 8 goes into both of those. 8 goes in here 5 times. 8 goes in here 6 times. Let's check this one. 30, 36. I know 6 goes in here 5 times. 6 goes in there 6 times. We have to check all of them. Let's go 15 to 18. 3 goes in there 5 times. 3 goes in there 6 times. So look, my ratio, 5 to 6, 5 to 6, 5 to 6. This aligns square. So we can say, yes, the shapes are similar. Yes, they are, because they meet square. Let's look over here. Now this one, careful. Do you see these lines here? Notice they match this way, so it's rotation. So the first thing you notice, that for these to face the same way, I need to go like this. That's going to be 36 and 30 if I want to keep the double arrows on top. Okay, and then this one is 30 and 25, double arrows on top. So our angles may be congruent here, but if you check the sides, the 30 to 36, 6 goes in there 5 times, and 6 goes in here 6 times, 5 goes in here 5 times, 5 goes in here 6 times, and so you notice the ratios are equal. So this one is yes, it's also similar. Now we know the shapes are similar, so now we're going to use proportions. You have to match the sides up. So 24 is short, 28 is short. So I'm going to go left to right, match 24, 28, mirror the direction, long to long, 30 over unknown. Cross multiply. 24x equals 30 times 28. Notice I did not actually multiply there. I'm going to do 24. Coming real close here. I'll do this real slow. 6 go, excuse me. I'm going to go ahead and I can work either with the 30 or the 28. I know 4 goes in the bow, so I'm going to use that one. 4 goes in here 6 times. 4 goes in here 7 times. Now I'm going to take the 6 into the 30. 6 goes into 35 times, so my final answer here is 5 times 7, which is 35. If you did it a different way and you got the exact same answer, for goodness sake, you're fine. First, I have to align my sides here. Short with short, medium with medium. This is where colors come in handy, long with long. I have a set of sides on the short and the median. It doesn't matter which one I choose. I'm going left to right. Cross multiply. I know 30 and 15. 15 goes into 30 twice. Therefore, my final answer here is going to be x equals 40. And if you look really carefully, that makes that a 3 to 4 ratio all the way around. Following shapes are similar. Solve for the unknown. Take a look here. My scale factor is A, 2 to B, 3. So A is 2, B is 3. Notice I color-coded. It makes it easier. So I'm going to go A to B, 2 to 3. Notice the direction I'm going. So then I'm going to do x plus 3 small with the large 21. Cross multiply. Now let's see if that's actually true. If I stick an 11 here, that whole thing gets me 14. So 2 to 3, 14 to 21 does reduce to a 2 to 3 ratio. So I know my x does equal 11. Watch my ratios. I'm going to go from A, which is 3, to B, 7. Careful, your A is on the right this time, so my 3 goes there. My B is 7. So if I want to start 3 to 7, this direction, I have to finish this direction. Now, just for giggles, I'm going to show you a shortcut. I know that 3 will go directly into the 36, so rather than distribute the 3, I'm just going to divide it out completely. So that 3 cancels that 3 on the outside. It doesn't touch the parentheses. 3 goes into 36 12 times. Now I can do 7 times 12 right here. 84 minus 27, both sides. 84 minus 27 gets me 57. And I divide by 3. And I know 3 goes into 5 one time. 2 left over, and 27, that's going to be 9. So I know my x is 19. And all you need to do is plug it back in, and you'll see that that proportion works. Make sure you actually take 2 minutes and verbally summarize the 4 things you learned in this lesson. 4 things. Flip back to the front and go through those 4 things, and that will help you remember what we're doing.